Let us consider the distance between an electric dipole is 2a. O is the midpoint of an electric dipole. A point P is placed at a distance of r from the midpoint of O of the dipole on the equatorial plane, that is perpendicular to the midpoint of O. Due to this, PA is equal to PB. Because of this, the magnitude of electric field produced at P point due to positive charge is equal to the magnitude of electric field at P point due to negative charge. But the directions of the electric field vectors are different. For a positive charge, the electric field vector, that is E plus vector, is away from this positive charge. For a negative charge, the E minus vector is towards the negative charge. According to parallelogram vector addition, the resultant vector E total is towards the right side. I already said P is equal to PB. So that PAB is an isosceles triangle. Due to this, these two angles are equal. If this angle is theta, then we can say this angle is also theta due to corresponding angles are equal. And this angle is equal to this angle. This angle is equal to this angle because alternate angles are equal. These two lines are parallel and PB is the transversal, so that these two angles are alternate angles. To take E total vector, we have to take component for E plus vector and E minus vector. E plus vector is forming theta with the horizontal line, so horizontal component is magnitude of E plus vector into cos theta. Similarly, for vertical component, magnitude of E plus vector into sin theta. Similarly, we calculate E minus vector. Horizontal component is magnitude of E minus vector into cos theta. Vertical component is magnitude of E minus vector into sin theta. Comparing this vertical component, both the values are same, but that is magnitudes are same and directions are opposite in direction. So adding these two values, it will be nullified. So E total vector is equal to sum of this horizontal component. So before adding these two values, we see dipole moment vector. Dipole moment vector is always from negative to positive, but the resultant vector at P point is uh, opposite to this P vector. So we can consider this P vector as minus P vector. So E total value becomes minus into magnitude of E plus vector cos theta P cap minus magnitude of E minus vector cos theta P cap, where P cap is the unit vector. Next, we have to find out AP distance. APO is the right angle triangle. So, in right angle triangle, hypotenuse square is equal to side square plus side square. So, here AP square is equal to OA square plus OP square. Substituting OA and OP value in this equation and taking square root on both the sides, we get square root of A square plus R square. It can be written as A square plus R square all to the power 1 by 2. So E total vector is equal to E vector plus E minus vector. Magnitude of E plus vector is equal to magnitude of E minus vector. First of all, we see what is electric field vector. Electric field vector is nothing but force per charge. That is charge at P point. So we can consider the charge at P point is QP. Force can be calculated according to Coulomb's law, that is K into Q1 Q2 by square of the distance between the two charges. Here Q1 is Q plus and Q2 is QP. Cancelling this QP on both the numerator and denominator, E plus vector is equal to K into Q plus divided by square of the distance between the two charges. K value we can substitute as 1 by 4 pi epsilon naught into Q by distance between the two charges. The distance between the two charges is A square plus R square all to the power 1 by 2, that is whole square. And the denominator, see the power values, that is 1 by 2 into 2. We can cancel this 2. We get magnitude of E plus vector or magnitude of E minus vector. E total vector value we can return as minus 2 into, because magnitude of E plus vector is equal to magnitude of E minus vector, so that adding these two values we get minus 2 into magnitude of electric field vector into cos theta p cap. Substituting this value instead of magnitude of E vector, we get this one. Next, we have to find out cos theta value. Using this triangle, we can find out cos theta. Cos theta is equal to adjacent side by hypotenuse. Here, adjacent side is OA, that is equal to A. Hypotenuse value, we already found it. So, substituting these two values in this equation, we get cos theta value. Substituting cos theta value in this equation, we get this one. Then it can be written as, that is 2A q into p cap, we get this one. And on the denominator, this square root of r square plus a square, it can be written as r square plus a square whole to the power 1 by 2. So here the base is same, so we can add this powers, that 1 plus 1 by 2 gives 3 by 2. So we get minus 1 by 4 by epsilon naught into 2a q p cap divided by r square plus a square whole power 3 by 2. We know that p vector is equal to 2a q p cap. So substituting this p vector instead of these values, we get E total vector is equal to minus 1 by 4 by epsilon naught into p vector divided by r square plus a square whole power 3 by 2. If R value is greater than A value becomes negligible. So that the equation becomes minus 1 by 4 by epsilon naught into P vector divided by R square whole to the power 3 by 2. We can cancel this 2. We get minus 1 by 4 by epsilon naught into P vector divided by R cube. So we can use this formula to find out electric field due to an electric dipole at points on the equatorial plane.